Lesson 31, derivatives.
It says product rule.
It is product rule, but it's product rule for derivatives.
Oh, God.
Okay. So, what we've learned a good handful of derivatives already, yes?
Yes, ma'am.
We're still going to be using those derivatives, so they're not going anywhere because we're going to be using them within this. But what you have to look at is there's something called the product rule. When you have two pieces being multiplied, and you need to take the derivative of both of them. So like, I'll glance at example 1 real quick. Notice example 1 is y equals x squared sine x. There's two pieces in there. There's two factors, so to speak. There's an x squared. You know how to take the derivative of that, yes? There's also a sine x. You know how to take the derivative of that. Now, the key is, when it's adding, yes, you just take the derivative of each piece and you keep moving on. This one, though, because they're multiplied, we have to use something called the product rule. Okay? So, the product rule is what you see up here. So, if you're trying to do the derivative of f times g, basically you take turns taking the derivatives. So, you do, and you can do this in either order, but what this is derivative of f times g as is. Plus, then it's derivative of g, leave f as it is. So it's basically like, take the derivative of the first item, leave the second. Plus, now it's keep the first item, derivative of the second. Okay? So in our problem here, where it's let y equals x squared sine x, it's the idea of saying this x squared is one of these, so you could call it f, and the sine x is the other one. So that's like the g. Take the derivative of one, keep the other. Then since it's product rule, we're going to add, and then just reverse the situation. Okay? So let's try it. Y is x squared sine x. So you're asked to find y prime. The derivative of f. So what's the derivative of x squared? 2x times you keep the sine x as is. That's a product rule, so it's plus. And this time, you keep the x squared, and the derivative of sine x is cosine x. If I go with the notation up here, it says really derivative of sine x is cosine x, then times the x squared. It doesn't matter though, right? Honestly, when I clean this up, I am more likely to write this as 2x sine x plus x squared cosine x. That's what I'm likely to write that as. Now, you guys all realize I could also totally flip-flop this and say x squared cosine x plus 2x sine x.
Yeah, that's unnecessary.
I mean, it all comes down to is which piece did you take the derivative of first. And I honestly can't remember which way it'll be in the book, but let's see. I did not hear. We'll talk in some of them, more a couple of the next two. But factoring a GCF out, they'll sometimes do that to express the answer. So, okay, so you ready for example 2 then? F of x equals x squared e to the x. You're being asked to find f prime of x. Thoughts?
You want to do the same thing with x squared and then do that.
How did you say that? Sorry.
I said do the same thing as before, but with, you
Okay.
know, x squared and get x.
So derivative of x squared is 2x. Keep the e to the x. Then it's a plus. Yeah. So, and if you prefer, you can say it's keep the x squared. Derivative of e to the x is e to the x. Now, you can write your answer as that. Okay, there's no, wrong or right. If you're just writing a derivative, you could write it as that. Keep in mind, something like this on the AP exam could be in multiple choice format. So you come up with a derivative answer of that, but they go ahead and factor it. You need to recognize the equivalencies, right? And so what is a GCF we can factor out here? And x. So really, you can factor out an x e to the x. If you factor out an x e to the x, what remains? 2 plus x. I agree with Logan. Okay. Both of these answers are correct, right? I'm not saying that at all. This factoring format, derivatives will help us find certain aspects of graphs and stuff. So that will be important in other aspects, and you will want to be able to factor it. Okay. Example 3. There's a couple of different ways we could think about this one. So let u equal the natural log of x, v equals 2e to the x, and y equals uv. Find y prime. What would you like to do? Okay. Could we go ahead and plug them in? And that's what I figured you guys would go for, and that's fine. So if y is uv, then y is okay. However you want to write it. I wrote mine as ln x times 2e to the x. You can put the 2 wherever. It's going to work out the same in the end. And actually, it does look like, because the other way that I wrote it is I actually wrote 2e to the x ln x. And that way, I didn't have to necessarily have the multiplication dot in between. But again, it's all the same.
I don't like the dot.
Okay, y prime. Okay, so you're keeping the 2e to the x and taking the derivative of ln x?
Yeah, the second one would.
Okay.
I didn't understand what you said about the first part.
Yeah.
Well, and he said it in a slightly different form, which is equivalent. So, if what he did is he kept 2e to the x. He did just the opposite. And then he said the derivative of ln x is x to the negative 1. What do we think of it? What do we normally think of it as? 1 over x. Now, again, are they equivalent? Yes. Traditionally, we write it as 1 over x. So I am going to write it as 1 over x, but I'm not saying the x to the negative first is wrong and then I'd count it wrong.
It is wrong.
Now, if your friends have a different judgment, that's their choice. But okay. So this time he kept the first derivative of ln x. Now reverse that, right? So we're going to keep the ln x. And what's the derivative of 2e to the x? 2e to the x. So this one's going to be 2e to the x ln x. What's the cleanup I could do there? So you can factor out 2e to the x, and then I'm left with 1 over x plus natural log of x. Okay? Are you getting the hang of this product rule? Because here's the key. When you go to do homework, you've got to remember when you see 2 things you can take the derivative of. You don't get to just take those derivatives and write them next to each other. You have to apply the product rule when there's 2 pieces being multiplied together.
This is not like math so much more than physics. Because in math, there's like set equations. In physics, it's just like, find it.
Just do
There's
it.
equations to find it, though. It's
Yeah,
just
but it's always different. It's like the sum of the forces equals this force
Gives them a really good memory too. Very good memory.
Squishing those inside of triangles.
Just wish there wasn't a piece of
Not like
Okay.
imaginary triangles that come out of nowhere. It's like, oh, nice.
f of x is e to the x cosine x. Determine f prime of 1.2.
Whoa. Yep.
You have to find the derivative first, then we'll substitute the 1.2 in at the end. So, derivative of e to the x, keeping the cosine x, plus, keep the e to the x. What's the derivative of cosine x? Yep. Negative sine x. I heard him say yeah. Did he give you a look? I heard him supporting you. Now, for cleanup purposes, you could factor out e to the x, and then what's left in the parentheses? Cosine x minus sine x. And then to do f prime of 1.2, plug it in. E to the 1.2 times cosine of 1.2 minus sine of 1.2. You guys got the calculators going?
Is this radians?
Good question. Is it radians?
It doesn't say degrees.
Okay.
I'm going to fail my physics test now.
Okay. So as soon as we get done with this problem,
That's why I'm not changing it. I'm not gonna
what I'm going to say is as soon as we get done with this problem, we'll all make sure together that you change it back, okay?
Everyone like on the count
So,
of three.
I'm just saying, we're going to remind each other because I don't want to, yeah. Of course, this is the day you actually need radians.
Purpose so we can have a chance to redo the test.
No guarantee he'd let you redo the test.
It's right there now.
I should probably start trying in physics. Maybe he'll make his son do it.
Okay, let me know what you guys get.
Should it be a negative number?
Yes.
Yeah, there you go. Okay, cool. The rest of it?
Go ahead.
I got -1.89140862.
Me too.
Yeah.
That's about right.
You want to repeat that again?
Say the whole thing, Trevor.
I got -1.8914.
That was it?
I think there was more
08629.
Is that it?
So what was the beginning?
Say it again, Trevor.
One more time.
I'm not saying it's none.
What was that, Trevor?
I thought we did. He was like, yeah, you say it. Trevor's voice.
I knew that neither one of them were going to say it for a while, so I was
For a while. He was like, I ain't waiting for this.
Okay, so
I'm proud of you, Trevor.
valid point. It did need to be in radians because there's nothing indicating degrees. It's non-labeled. I did it on my calculator in two different ways. Technically, do you remember me introducing that you can do derivative specific values on your calculator?
Yeah.
So,
That button.
yeah, right here, the second thing I did is what you guys did, right? Like Trevor probably had that negative 1.8914088629. Okay? Notice my answer is slightly different up here, but remember you go into the math menu and there's that in deriv. You can type in the original equation and an x value. Now, it won't find the derivative of e to the x cosine x, but it will find the derivative evaluated at a certain value. Okay? There are times you will need to know that. There are times you need to do it by hand. Remember, this AP test is half pen and pencil, so not calculator is what my point was.
Unless you're really good at hiding your calculator.
Okay, yes. Degrees?
Okay.
Are you in degrees, Logan?
Yes, ma'am.
Are you in degrees, Trevor?
Yep.
Nathan?
Yeah.
Mallory, did you ever leave degrees?
No.
I
I didn't take
Barely good physics. Your degrees? Are you guys all? You never changed either, did you? Have a calculator today, don't you?
Yeah, my locker.
Okay.
In my locker.
That's fine for right now, but I'm just thinking for physics, that won't be fine. So, okay. So we're all safe then.
When I was like middle school ones, I had like it's just simple addition.
Here you go. Which technically, does this work for physics, or do you have to have some of the graphing?
We haven't graphed yet. That
Is
one's
it-
a problem.
Wait, doesn't it have sine, cosine, and everything on there? Oh,
Yeah.
yeah, then yeah, that would work.
I think-
That's scientific.
He-
That has cosine.
Yeah, it has your sine, cosine,
Yeah,
tangent on
as
it.
long as it has that on it, then it's good.
Although, is everyone in AP Physics either in pre-calc or calc,
Yeah.
or had pre-calc last year? So that means everyone would have the graphing calculators anyways. So, interesting. Never thought about the calculator aspect of that. Okay, example 5. Unsidetrack here.
What if you never took pre-calc or calculus and you took physics?
I don't think you can't.
Really, actually?
I think it's a prereq. I mean, really, pre-calc should be a prereq for physics, for AP
Yeah.
Physics, really. But okay, let S equal x squared y cubed. Find ds.
Stop. She does that once, like every 10 minutes.
I know, it's always stuck in my head.
Probably ever since
Okay.
that one kid said you got
Now.
McDonald's terrible.
Notice what's different about this one, guys. It's ds. Notice there are 2 variables in there.
Yeah.
It's still a product rule, yes?
Yeah.
So what we're going to use is, remember talking about differentials the other day. Okay. I think it was just yesterday, or was it the day? No, it was the day before. Yesterday was graphs. You remember differentials, Mallory? So
Yeah.
it wasn't yesterday then.
Yeah.
So,
Yeah, yesterday we had pizza and watched Wall-E.
Zero.
Oh, yeah.
Good.
We meant to tell you.
Okay. So, here's what we're going to do. We can't say just ds like dx or ds dy because there's both.
Yeah.
So each time we're just going to use the differential every time we take a derivative. So the derivative of s is like 1, right?
Yeah.
But then we're going to say what variable is that in relation to? S. And so that's a ds.
Like Nintendo.
Sure. Now, x squared y cubed. Derivative of the first, keep the second. What's the derivative of x squared? 2x. What variable did you just take the derivative of? X. So I'm going to say 2x dx. And then what still hangs around? Y to the third. Product rule says we add.
And do the opposite.
So now we're going to keep the
X squared.
x squared derivative of y cubed. 3y squared, what variable did we take the derivative of? Y, so we're going to say dy. Now, the only thing we can do with this is clean it up because they asked us to find ds. When I clean up, normally we put our dx's, our dy's, those kind of things, those differentials at the end of the terms. So this first one, like I would say 2x y cubed dx. That dx does not have to be right next to the x. Plus x squared times 3y squared. I like to put the constant first, so 3x squared, y squared, dy. Does that sound familiar?
Yeah.
Yeah, I remember that.
Okay.
I'm just dumb.
I mean, if you want the alternative of why it works, here's my side note. If we just had s equals x squared, right? And I ask you to find ds or ds dx, right? We could say the derivative of s is ds dx, right? When you put that dx under there, then when I get to the right side, well, what's the derivative of x squared? That's just 2x. And then you don't have to put the dx because it's already on the other side. And then you can multiply the dx over,
Yeah, we did that.
and ds equals 2x dx. Now, could I have cut out that middle step there?
Yeah.
Yeah, you could cut out that middle step, and the derivative of s, or the derivative of s is 1 ds, derivative of x squared, 2x dx. Okay? Does that help connection some?
Yeah, definitely not skipping the middle step ever.
Well, we did kind of skip the middle step here, though,
Yeah.
because it was x's and y's, so. Okay. Last one? There is no backside, right? Yeah. Y equals s squared sine t, find dy.
We gotta do the same thing.
I agree, same thing, yes? We're trying to find dy. There's an s and a t, so think in terms of differentials again. What's the derivative of y?
dy.
Dy. Or 1 dy. Okay. Derivative of
2x
s squared is 2s
times sine t.
Then what? We took, since we're using differentials, we took the derivative of the s term, so don't forget the ds, which she didn't say, so I didn't write it down, but I kind of left the blank there, making it obvious.
Yeah.
And then what? Plus? Yep. Keep the s squared. Derivative of sine t is cosine t dt. Let's see. Is there cleanup? I can clean up the first term a little bit. dy is 2s sine t ds plus s squared cosine t dt. You could throw in some parentheses in there around certain pieces to kind of separate. That does look a little confusing there with 2s sine t ds, but you can throw in some multiplication dots, you can throw in some parentheses, you could leave it. Okay,
Clever person.
and that's it for 31.